Welcome back to Maths with Mrs. J. I'd now like to do with you a very interesting question known as the birthday question. If someone said to you, what do you think the chance is that in a class of 30 students, at least 2 students will have the same birthday? You'd probably think that it's not that likely. 365 days in the year, 30 students in the class, plenty of birthdays for everyone to have their own, hey? So you wouldn't think it's all that likely. I'm going to prove otherwise. It's actually a lot more likely than you think. In fact, it's more than 0.7. Okay, let me show you why and how. What we're going to do here is we're going to use complementary events. So we're going to say the probability that at least 2 have the same birthday is the complement of everybody having different birthdays. Okay, so 1 minus probability everyone different birthdays. So that's our first step. Otherwise, it's too hard to do if you don't use complement of an event. Complementary events are often very useful in situations like this. Okay, so how are we going to work out the probability that everyone has different birthdays? Well, this is going to be a conditional probability situation. Okay, well, the first person on the roll of the class could have their pick of all the birthdays of the year, 365 out of 365. Now that day is now taken. Okay, that day is taken. So the next person, you've still got 365 days of the year to choose from, like that exist, but they can only have 1 out of the 364 that are left. Okay, because the first person has now dibsed 1 birthday. So there's only 364 choices available if you, not that you choose your birthday, but you know what I mean, 364 days available for the second person, because we're assuming here, we're trying to work out the probability that everyone has different birthdays. Right, the next person, well, still 365 days in the year, but they could only have their birthday on any of 363 of those days. Now we're going to keep that up until we've done 30 fractions. The last fraction obviously will have 365 on the denominator, and then on the top it'll be 336 because you're going to have 30 of them. So this is going to be 1 minus, well, this will be 365 raised to the 30, and this will be 365 times 364, etc., all the way down to 36. If you work that out on a calculator, this part here is about 0.29, approximately. It's a bit messy, but it's about the 0.9 value. So 1 minus 0.9, of course, is about 0.71, which is quite surprising, really. So there's more than a 70% chance that even in just a class of 30 students, that at least 2 people will share a birthday. It's surprising, hey?